Assalamualaikum, hello everyone. In this video, we are going to learn about noise control. This lecture is the continuation from previous lecture, so it is very important that you understand previous lectures in order to understand this one. Let's start with understanding noise. So what is noise? Is it loud sound? But musics are also loud. So the difference between music and noise is the sound pattern. Music is more regular and harmony, while noise is irregular and non-repeating pattern and also random. However, people may argue whether heavy metal songs are considered as noise or music. The thing is, whether it is a sound or a music, it depends on listeners' perception. Whether or not a sound is undesired by a person depends on several factors. It will be because of loudness, frequency, continuity, variation with time, time of occurrence, maybe during late at night, okay? The sound that you perceive as very nice during the day will be very annoying during the night time. Information content, it will be also based on the origin of the sound, the background noise music, and the recipient's state of mind and temperance. So it is very subjective. What are the sources of noise? Noise can be from airborne and structure-borne. It can also be either from the outside of the building or inside the building. For noises from outside the house like transportation, sounds are transmitted through the air and then through the structure of enclosed building or through air for opening like windows. Similar process happen for noises inside the house, airborne and structure-borne. Here are some examples of noises. From airborne, there's air jet, basically transportation, from construction site, from highways, and structure-borne can be from mechanical equipment, neighbors' activity, again construction site, and others. So what are other sources of noise? Now, in previous lecture, I already shared this table with you on an example of noise source. The noise level and how long it takes to bring risk to hearing. But what does it mean by risk to hearing? So noises can lead to temporary hearing loss, permanent hearing loss. It can cause stress or irritable. It can also lead to habit of shouting, psychiatric disorders, and speech interference means you can't hear clearly what other people say and may reduce work efficiency, and it can cause other auditory and non-auditory health effects. Okay, auditory are like these two. So, statistics from Department of Occupational Safety and Health Malaysia, OSHA, shows that the most reported case for occupational disease and poisoning in 2017 is noise-related. It is 5 times more than the next occupational disease in this table. Now let's see what are the design approaches for noise control. To reduce noise, measures can be taken at source, path, and listener. Example of noise reduction options at source are maintenance, relocate the noise source, you can redesign the source to be quieter, and others. So usually the designer part is for engineer, okay, design the equipment. We can also controlling noise at path like enclosing the noise source, install barrier, isolate vibrations, and etc. The last one is to control add listener, like relocate the listener or add masking sound to listener's location, and a few other ways that you can read here. So based on previous examples, we can control the source by using a quieter model. You can control at path by adding barriers like wall or shrubs, and can also control at listener by add masking sound, for example water feature. But we are not only the designer. Okay, remember, as architect you are not only designer for in path and at listener. An architect also responsible to design at noise source. For example, let's say you are designing at housing area and your client loves making furniture and want a carpentry area. Now, instead of locating it next to your neighbor, you can relocate and place it at a more secluded place. However, it is more effective to cater at the sound source than to solve it at the receiver's level. An example of eliminating noise at sound source is by physically remove the hazard or replace the hazard. Noise reduction at in-path level is by isolating people, which are the noise receivers, from the hazard, while at receiver's level are by changing the way people work, or the least effective method is by using personal protective equipment. Now, PPE for noise is not this PPE, okay? So this is PPE for infectious disease. PPE to protect ears from noise are ear muffs or ear plug. We are going to explore the noise control methods based on these four groups: acoustical site planning, acoustical architectural design, acoustical building construction, and barrier. In these few slides, we will learn on how to control noise at site planning level. So it can be by increasing the distance. We can place non-residential land between the source and the receiver. You can locate barrier type buildings parallel to the noise source, okay, for example highway, to the user, and then we can orientate the building away from the noise. The last one is by cluster and planned development. So for each slide, I put a note here for the sound behavior that each noise control used to reduce noise. It's here. So the first noise control method at site planning level is by increasing the distance between source and receiver. So let's refer to the illustration here. To solve noise issue, let's say by a nearby road or commercial area, you might think that we can just add barrier. Okay, add barrier wall, settle. So it might work for 1 or 2 story building, but what about multi-story building? So what can be done is to increase the distance between the source and the receiver. So this will reduce the noise because the further the source is, the less intense it is. Attenuation. We can also add noise compatible land like car park or maintenance facilities or utility area as the buffer between noise source and receiver. And then next is by buildings as noise shields. So when doing site planning, a long building or multiple buildings parallel to the source can also act as sound shield. So this building can be noise compatible, or if it is sensitive to noise, the building can be soundproof. So this approach is using both reflection and absorption. Okay, next is orientation. By orienting the building differently, noise can be reduced at most part of the building. For example, a U-shaped building facing the road receives the most noise and can even be reflected here at the center of the building. However, if you oriented it away from the noise, okay, and most of the sound will be reflected out here, but this part here need to be insulated, or maybe the spaces here are noise compatible. Okay, next method is by cluster and plan unit development. So you are familiar with grid arrangement, right? For terrace houses, for example. So remember how easy it is to hear what the sound and noise your neighbor make, and how you can hear sounds from nearby noise, for example, major highway or from nearby LRT station. So by placing buildings in cluster arrangement, noise can be reduced because each buildings are further away from each other. So there are more trees and a few other factors here. Okay, so however, this one need more land. So more land here, but less noise. And this one, of course, it's harder to reduce noise, but you can save land use. So next, we already finished on planning just now. So next is on acoustical architectural design. So let's see how to reduce noise by acoustical architectural design. So space arrangement, walls, shorter buildings, for buildings near highways or any other noise source by having balconies. There's another approach by podiums, by using podiums for higher buildings and courtyards. So of course, there's also a few other methods, but these are the main one that I will share with you. The first one is by space arrangement. If the noise sound is from here, less noise sensitive rooms can be located near the sound source, while more noise sensitive rooms can be placed further away from the noise source. So noise can also be reduced by eliminating windows and other openings from the wall near to the noise source. So the solid wall can then have the effect of a sound barrier for the rest of the building. When a solid wall is impractical, illegal, or highly undesirable, the same effect can be achieved by reducing the window size and sealing windows A-type. In cases where there are barriers, use shorter buildings for buildings located near to the sound source. This is because the barrier won't be able to shade the upper level from noises. Now balcony, next is on balcony. So balcony is a space for activities outside the building wall, like relaxing, reading books or gardening. So the best way to avoid noise is by locating it away from the sound source. However, if it's not possible, use solid material as railing to reflect noise and install insulation at balcony ceiling to avoid noise reflection into the building. So the insulation can be as simple as the normal ceiling board. Okay, for tall buildings, podium can work as sound barrier. The first image shows that without podium, the noise level is much higher than with podium. Note the noise level here. But this one, with the podium, and over here will become the acoustic shadow area. And note here, the noise level is much lower. So similar to balcony, courtyard is for exterior activities. So it's the best to avoid placing it next to the noise source. So just now it's all more on designing. So now this is what we usually focus on, noise control by acoustical construction. So I'll list here, we're going to explore this, okay, in the next few slides on the 7 approaches on how to reduce noise by using building construction. So actually there are more ways, okay, so these are the more common ways to reduce noise. Now the first one is wall. So noise control by wall construction, so I listed here, okay, how these factors affect sound in attenuation. For example, increase the mass, and then we can also add airspace, increase width of airspace, wide spaces between studs, because noise can transfer through structure bond, remember that. Staggered studs so that noise won't transfer again, so that there's a gap here. Increased use of resilient attachments, dissimilar panels, okay, so use different material with thickness layer, different thickness layer. And you can also add sound insulation. Remember just now the attenuation, what does it mean? Sound reduction, okay. So in this slide, this one are walls with STC level. So STC is sound transmission class, STC. A rating of how well a building partition attenuates airborne sound. Common construction for buildings in Malaysia is this one, 4-inch brick wall. So the STC is 40. So let's see how good STC 40 is. So STC 40 is around here, between here. Let's just take this one. So loud speech can only be faintly heard. Normal speech cannot be heard. So that is good enough for housing, but may need to be improved in some other building type. Now next is windows. There are 4 design suggestions for windows in this lecture. The first one is by making it fixed window. So if needed to be openable, if you want to open this one, seal can be added around the window. So when you close it, it will be similar to fixed window. Second option is by reducing window size. So this option have limitations because we still need to consider view, needs of natural lighting, building requirements for minimum opening size, etc. The third option is by increasing the thickness of the glass. So this option is by taking the principle of higher mass, more noise resistant. The last one is by installing double glazed windows. So the performance of double glazed windows can even be increased by increasing airspace width. You can increase the glass thickness. You can use proper sealing. You can have a slightly dissimilar thickness of the panes and slightly non-parallel panes. So after windows are doors. Acoustically, doors are even weaker than windows and more difficult to treat. So any door will reduce the insulation value of the surrounding wall. So some of the approach to reduce noise is by using solid door instead of hollow door. So solid door is like this. Okay, hollow is, of course, it's hollow lah. Okay. Similar to window, we can also add seal around the door, and if possible, locate the door at area shielded from noise. So next component is ceilings. For your information, the normal ceiling that we see at studio or our home is good enough as sound absorber. So except in severe cases where maybe the noise is too loud, then we have to use better material. This is an example of how insulation at ceiling can reduce noise level in a building. So this is direct sound, the line here, and then this is reflected sound. So after installing insulation at ceiling, the sound that reaches ceiling won't be reflected to this quiet operations, this quiet working area. And then to reduce more sound, partition can be added between noise source and listener. Okay, for floors, noise travel at floors in both ways, from the upper floor to the below and from the lower floor upwards. So for the upper floor, when people walk or someone moving furniture or kids running, the sound will produced by vibrations made by the moving object and by this moving object and the floors. So the noise produced here are structure borne. But from the lower level, most sound are from airborne. So by the time it reaches the ceiling, the most of the sound are already reduced by attenuation, and most of the sound are reflected at ceiling here. Reflected. So usually the noise from lower level through airborne and through the floor is not very significant. For noise from upper level, one way of reducing it is by installing raised floor, and the noise can further be reduced by installing insulation material between the raised floor and the floor. So why this is to reduce the structure borne noise? You see the difference here. So another method to reduce noise from upstairs is by installing anti-vibration mats, or by installing drop, this is anti-vibration mats, or by installing drop ceiling. So you can do more research to explore other methods and technologies to reduce noise from upstairs. Okay, the next one is interior design. So basically the interior noise level can be reduced by the extensive use of thick, heavy carpeting, drapes, acoustical, ceiling tiles, furniture, and wall hangings. So this material cannot prevent noise from coming through the walls, but they can reduce overall sound levels by reducing sound reverberations. So what is sound reverberations? So we will learn this later in the next lecture. Okay, the last one under noise control for acoustical construction is masking. Masking reduces noise level by drowning it out with background noise. So noise wave is usually fluctuate and not uniform. By adding masking sound like water feature, soft music, or white noise, a more uniform sound can be produced. So this is an example of interior water feature as sound masking, so please design better than this when you want to design water feature. So sound masking speakers. Okay, the sound masking speakers are also available in the market. You can just buy this one. These speakers propagate random sound that does not carry information and harmoniously uniform. The last approach for noise control that I will share in this lecture is by adding barriers between noise and receivers. We are going to learn on earth berms, walls, fences, plantations, and combination of various barriers. So earth berm. What is earth berm? Earth berm is a long mound of earth running parallel to the highway. This one, okay, these two things here. So by having earth berms along the highway, traffic sound can be reflected and absorbed. So I'm going to repeat the animation again. So reflected, absorbed. Okay. So the image here, this one shows earth berms. You must be very familiar with this one because this is inside Malaysia. You must be familiar with this one too. I usually hate it actually. I hate this one because it blocks the view. Okay, there are a few materials for barriers, masonry, concrete, metal, polycarbonate, timber, and any other suitable material. So next is you can also another barrier for noise is plantings. So plantings for noise reduction must be in form of dense plants, okay, not just simple one layer of trees, for example. Now you might be surprised to know that while we love plants, solid wall is more effective at blocking noise than plants. So the principal effect of plantings is more to psychological. By removing the noise source from view, plantings can reduce human annoyance to noise. So basically, we cannot see it, so we consider that the noise is lower even though it remains. But of course, plantings are much nicer to see compared to concrete wall. So often, the last one, usually the most economical, acoustically acceptable, and aesthetically pleasing barrier is combination of the barrier types. For example, we can use precast concrete on top of earth berm, or can also use plantings in combination with barrier. So this is precast concrete on top of earth berm. So there are some considerations that we must take into account when choosing noise reduction method. For example, the noise reduction desired, how much you want to reduce it, the situation where physical technique will be more effective. We have to consider the cost, relevant administrative techniques, and aesthetics. For example, acoustical site planning is low cost but requires space and has to be planned forward. This here has to be planned forward before the building construction. So it is however have positive aesthetical impacts. And then acoustical construction is the most effective noise reduction for interiors compared to acoustical architectural design that is low cost but limited effectiveness. Is it true? Okay, so whether to know whether it is correct or not, you have to based on this you have to make your own table, okay, because each project are different. Okay, for walls and fences, for example, It can be poor to excellent in terms of effectiveness, but it is based on the material used. It requires little space and no maintenance, but may be aesthetically unappealing and can reflect noise to the other side of the road. So that's all for this third lecture. The next lecture will be on acoustic design.